All right, so today's the 8th. 11-8. You cannot teach a class that has anything to do with algebra at any level, algebra 1, algebra 2. Heck, if I taught like algebra 3, this lesson today would be an inevitable part of that class. Like no class can you survive until you check this off the to-do list. So 11-8, we are simplifying square roots. You'll sometimes hear it, like I think the Delta Math assignment will say simplifying radicals. And radical is a catch-all for all types of roots. So like it could be a square root or a cube root or a fourth root, but we are only going to do square roots. So Delta does not call it square roots, just FYI. So when you see radicals, that is, we're good to go. Don't sweat it, okay? So first off, I have to ask, do you guys all know, are you generally, bless you, are you all generally familiar with the symbol and what it means? That's the square root, right? It's the old school long division sign with that little notch on the end of it. Ooh, notch, Minecraft. That was my bad. That's on my mind. I'm so sorry. I should delete that from the recording. That was embarrassing. Um, what is the square root of 16? It is 4, right? So remember, the way a square root works is you're asking yourself, what would I have to multiply by itself to make the number on the inside, which is why the square root of 16 is 4. How about the square root of 81? What is that? 9. Good. How about the square root of 1? 1. Good. So what's nice about these so far is that these numbers I'm asking you are all what we call perfect squares. And so today's lesson kind of has two parts to it, really. There's the let's get to know all the squares part, and then there's the let's practice. You'll hear me sometimes say like good guy, bad guy. Have you ever done this before where you take a square root and you like break it down into two different square roots? Does that ring any bells? A little bit, maybe? Yeah. So even if you've never done this before, today's lesson will come at you from the level of you've never done this before. So it's all though predicated on the idea that you know what a square root is and that you know how to do it. Like the square root, if I put square root of 25, you're not going to say 12 and a half. You're going to say 5, right? We get that? Okay. So I've always written this list of numbers that we're about to write in red. I call it the red list. It just kind of started sticking with me 4 or 5 years ago. So the red list is something that I do want you actually to write down. Although your resources that Miss Orozco just handed out, they have them on there too. I think there's something though to be said for, kind of being part of the production or the construction of the list. So I put 1 on the list because I can take the square root of 1, right? Who's the next number after 1 that I could take the square root of? You cannot take a square root of 2. You can take a square root of 4. Now, when I say, who am I to bully you around? When I say you, quote, can't take the square root of 2, you can. It's just ugly. It comes out to 1.4, blah, blah, blah. It's what we call an irrational number. It's trash. It's going to be one of those decimals that goes on forever. So when I ask you for what can I take the square root of, I am, of course, meaning to get a whole number answer. So 4 is next in line. Who's after 4? Perfect, right? And after 9 is 16. So go ahead and get caught up real quick so that you're not playing catch up. If you intend to write these down, get that pencil moving and let's get going. Because I'm going to have you go up for a little ways here. And what's after 16? 25 is next on the list. I agree. And if you think there's some kind of wizardry at play, there's not. I mean, first off, there will come a point where you honestly just probably memorize these, but where they come from is not a mystery. So like 1 came from 1 squared, right? And 4 came from 2 squared, and 9 came from 3 squared, and so on and so forth. So this list you can produce by just squaring whole numbers. Just keep going in a row. It's easy peasy. What's after 25? 36. 36 is square rootable. I agree. What's after 36? 49. I agree. After 49? Let's see now if you guys can not look at your resources for a while and see how many of these you can figure out just from the top of your head. I'm honestly just curious. What's after 64? 81. After 81? I agree.
Please excuse me, election, we need this year's cross country team and last year's girls basketball team for the common.
Oh, and anyone who likes pepperoni on their pizza on Fridays. Okay.
I love Jordan, and I'm also proud of for her playing Division soccer, but I need to get this while my brain's still mushy because I can't. If I go there, then I'll just be checked out for the day. Love her, but I knew she was going. I knew that she was doing this, so it's really not.
So long story short, you're sticking this out. You're gonna
Yeah.
stay here. Are you sure?
Positive.
Okay. I mean, I won't judge.
No.
Okay. After 100? 121. After 121? After 144? After 169? After 196? After 225? This is usually where most people crap out. That's what I know it's where I would have. So for some reason we're familiar, a lot of us up to this point. Oh, well, that would explain why every year we crap out at 225. Now I know the secret's out. By the way, so to get 225, you would have had to do 15 squared. So the next one is 16 squared, and that's 256. And we're going to keep going. Okay. I like to go all the way up to 20 squared. I think it's good for the brain to just have a little extra info in there. Let's pack it up, fill it up. After 16 squared is 17 squared. 289. It is. You know, it has to end in a 9 because it ends 17 and 17. They end in 7s, right? So 289. And as always is the case, I run myself out of room. I've never taught this lesson and not run out of real estate on whatever board I've been using. So after 17 squared is 18 squared, which is 324. And after 18 squared is 19 squared, which is, it is indeed 361. And where I always stop, of course, is 400 because that's 20 squared. These are called squares. I call it the red list, but honestly, this list of numbers, all of these are called squares. Nothing, actually. I just didn't feel like saying the word perfect. So a square is something that is obtained by squaring something else, or conversely, a square is something that is square rootable. Okay. So when we talk about square numbers, I'm asking for like 9 or 100 or 64 or something like that. So let's get to the meat and potatoes of today's lesson. What we're doing, and by the way, if I pointed to any one of these right now, you should be able to tell me what the square root is. So like here, 100, what's the square root? 169, 36, 64. Right. And so it'll just, if you're a little rusty on those, it'll get quicker, I promise. The less you use your calculator, it'll get quicker and quicker. So what we're interested in today is numbers like this. So this is where the actual lesson starts, just FYI. What's wrong with 8? It's not a perfect square. And so today's entire lesson and today and tomorrow's work all revolves around the fact that I need in math to make that better. It's like a fraction. If you put like 12 over 20, your fraction still is technically correct, but every math teacher in the Northern Hemisphere would tell you that you should have 3/5 because you got to reduce fractions. This is like our new high school version of reducing fractions. No one says that it's okay to leave the square root of 8. And the reason for that is because 8 contains, watch for the yellow on the TV here in a second, 8 contains that number. And if the number that's inside your square root contains any of the numbers on that red list, then it's not okay. Then you have to go further. We call that simplifying. So I'm going to try this a little bit different. In the past, I've tried the tree, and I always say this to people. I say, if the horse you're riding on dies, get a new horse. And I feel like the way I've tried to teach this for a while is not working. So I'm going to try with you guys, not drawing a physical tree, but I'm going to try something different. because every kid who doesn't draw the tree and the root signs thinks they're going to outwit the system, and they all predictably make the same stupid mistakes. And so I'm going to try to avoid that because I care about you. So here's how we're going to do this. We're going to take the square root of 8, and right next to it, we're going to put equals, and we're going to make the square root sign a little bit longer. And what we're going to do is inside of that one square root sign, we're going to break up the number 8 into two numbers that multiply to make 8. And I want to make sure that one of the numbers is on the red list. And this will become an issue. Like 8 only has one way to make it, right? 4 times 2. And 4 is obviously on the red list. And so we're going to take 4 times 2. Notice how they're both inside the same square root sign, right? However, I'm going to refer to 4 as the good guy, because what is the square root of 4? So what happens is he becomes what I refer to as a jailbreak. And when something breaks out of jail, what it does is it square roots itself, and then its square rooted answer goes and breaks out of jail, and then nanny boo-boos the numbers that are still stuck inside. When 4 breaks out, he becomes 2. And who's still stuck in jail? So the answer, we say this, I'm going to put this in quotes for you. We read this as 2 root 2. That's how you say those. You don't need to say it longer, like 2 times the square root of 2. You could just say 2 root 2. Nice and concise. So if that made any sense, that's great news. If it made no sense, don't worry. We're going to practice a ton. And I mean a ton. So here comes your next one. And I'm going to take my red list off the board because I know you've got it handy there. So the next one I have for you is the square root of 45. So what I'm going to do is I'm going to put equals, and I'm going to make a little slightly longer square root sign to accommodate a couple of different numbers. Now, if you look at your times table sheet, the one that Ms. Orozco just handed out to you, you'll see that underneath the number 45, by the way, I'm talking about the sheet that looks, let me go and find it for you. Yes, I'm going to just put it on so that it can be on the recording here. It's the sheet that looks like this. This is your best friend because, and honestly, it won't help you when you go past 100. I'm sorry. But for anything 100 or lower, this is huge because it lays out every possible way to multiply to make a number. So when I look at the number 45, I see that I do have some options. By the way, 1 and 45 would never even have entered the discussion. That would just be stupid. But I do have 3 and 15. Why do I dislike 3 times 15? Because neither one of them are on the red list. So even though they make 45, this will not be the last time I say this. Even though they make 45, they're dead to me. They're trash. So who obviously do I want? Yes. Careful. Don't go too fast. Let's slow down. I like what you've said so far. And by the way, I will always, and I mean me always 100% of the time, put the good number first. That way there, it's got a shorter journey to break out of jail, and it matches the format of the answer. So if you put 5 and 9, it's okay. I'm always going to put the 9 first because you agree that 9 is a good guy, right? What is the square root of 9?
3.
It is 3. So when 9 jailbreaks himself, then the final answer is 3 root 5, we say. Okay. Let's go again. And if you're interested, the other way I used to teach this is with little tree branches and little square root signs like this. The trouble is, no matter how many hundreds of times I told kids to put the square root signs, there was always that percentage that thought they just should ignore me like I was some kind of quack. And so I figure this way here, I'm kind of, if you do it this way, you're forcing yourself to still have both numbers inside of a square root, which I think is pretty cool. So what am I going to break 27 up into? 9 times 3. And again, 9 is going to be my jailbreak, and he's going to break out, and he'll be exactly, Dalton, what you said, and Aubrey, what you said. Good job. 3 root 3. Okay. Let's bump it up a little bit. So this is where the game changes starting right this moment, because I'm going to try giving you now more, not every problem, but more. You're going to see more problems where there's more than one quote unquote good guy. And this part of the lesson, if I could ask so kindly of you, this next like minute or so, I really would like you to laser in and tell me if what I'm going to say doesn't make sense. This is year number 29, I think, and I've yet to really get this point across. So give me just a good moment and let's see how this goes. If I'm scanning through the red list, the very first thing that I find, and I know a few of you probably already know what the right answer is. The first thing I'm going to find, if I use like a calculator maybe, is I'm going to go, it's easy. I did it. I found 4 times 50. And why do we like 4? Because it's on the red list. And this is the part where I need you to listen carefully. That is not a good choice. Because even though 4 works, there's a better choice out there. And I know that and I'll be really proud if you can answer this question. I know there's a better number out there because 50 is not what I call a dead root. Can you look at the number 50 and tell me if it's got more to give the world? What does it have to give the world? On the red list, does 50 contain somebody on the red list? What? Yes. And this is the part where you can ask me very nicely, please. Don't even ask nicely. I'll say this part again and again and again if I have to. Do not pick a number. Look at where my green arrow is pointing. Do not pick a number to put there just because it works. Put a number there once you're sure it's the best number that works. And you'll be able to tell it's the best number that works when you look at the guy up there in the yellow circle and can say, you're dead to me. You contain no more 4s and 9s and 16s and 25s. Clear? Moral of that long story is this: don't settle. Don't pick the first one you find and go on your merry way. You can still work it. It's just a pain. So having said that, let me go back in time and let's act like this didn't happen. Can anyone think of a much sweeter, huge combination of numbers that makes 200? Yeah. 100 times 2 is a jackpot. It is perfect because yes, 100 is rad because 100 is huge and 100's on my red list. But how can I look at this number 2 and know that I did well? What is 2? Trash, right? You can call it a dead root. You can call it a trash root. Come up with some name for you that works. But your job is to be able to look at the second number and say, you're dead. You're trash. You're garbage. You got nothing left. You don't have any more red list numbers to give me, right? Now, having said that, when 100 jailbreaks, what does he become? So the answer is 10 root 2. How about this one? You know, I'm not entirely opposed to this nice Minecraft music on in the background. I wonder if it facilitates learning. Yes. So it's okay to use any resources other than like Photomath. Anything that will do all the work for you is obviously banned. But any sort of resource that would be allowable generally on like a test or a quiz is fine. A calculator or the resource sheet, and you will figure out, Len Aubrey already said it, that 98 breaks down into 49 times 2. And we love 49 because he is square rootable, right? So when 49 jailbreaks, what does he become? 7 root 2. Okay, how about this one? I call this quarter math. I always think to myself, I started saying this years ago, and I was like, man, why didn't I think of this 20 years ago? I asked myself, could I make that much money? If someone said that'll be $1.25, could I make that money in quarters? And if I can, you might wonder, why am I talking about this? Because a quarter is 25 cents. And 25 is rad because it's on the red list, right? So I ask you, could you make $1.25 out of quarters? How many quarters would it take?
5.
Wonderful. So that tells me then that I can take the 125 and I can break it into 25 times 5. Exactly 5 root 5. I call that quarter math. Anytime I see something that ends in something that has a little quartery vibe, like a 50 or a 75 or something, I think, could I make it with quarters? Because quarters are 25. 25s are awesome. So far, so good? Okay, this next section of the notes I'm giving you as a gift. What I've done is over the years, I've figured out that these next 7 numbers account for like 95% of wrong answers. So I call these, I decided to start, it sounds awfully overly dramatic, but I decided to start calling these the death numbers, which again is very like, ooh, you know. You're going to think I'm crazy when I show the first one up here. You're going to think you're crazy, dude. It's such an easy, friendly little number. It's like a little cute little kitten. And you think, how could 32 be a death number? If someone did their job, and by someone I mean like your 4th grade teacher, you immediately, when I put up 32, should think of 4 times 8. That should be like a conditioned response. 4 times 8, 4 times 8, 4 times 8, because I know that someone got paid to teach you a times table grid that goes from 12 to 12. Am I right? And 4 times 8 is situated beautifully right in there 2 different times. And you know, like clockwork, that 4 times 8 is 32. So 32 is a trap, because if I pick the one that my 4th grade teacher wants me to pick, why do I know that 4 was not the best choice? Because 8's not dead. Because if I can look at the other number that's not on the red list, 4 is good. He's on the red list. Yay. But if I can look at the other number and say, you have more to give, then I know I've chosen poorly. So 32 is a trap, because you're going to want to say 4 times 8 until I'm done with you. It is 16 times 2. And that's what I want you to put into your notes, is the correct way to break down the square root of 32. Always please use 16 times 2. Which gives us 4 root 2. What's up, dude? Excellent question. And this question was going to come up eventually. Would I take that 4 and square root it down again? I get this question dozens of times per year. The answer is emphatically no. Where did this 4 come from? It was already the square root of somebody else. So again, I get that's an excellent question, and I get it every year. Once you square root a number, it's game over. You don't get to keep beating him down, right? Please, you don't even have to ask, buddy. I'm sorry that so many places around this school don't seem to respect like just sitting in class and doing work, but we can control what we can control by shutting that door. Thanks, Dalton. I know, right? That's progress. All right, the next death number on my list is 48. And I have to tell you again, I know exactly why kids miss it. It's because they think of the things that were on their times tables. Assuming you're a kid that learned your tables, you think of 4 times 12. Or you think of 6 times 8. Why is 6 times 8 just utter complete trash?
Because 8's not dead.
No, it's worse than that. Why is 6 times 8 real trash? You're still not answering my question. Why is 6 and 8 uber trash? If I picked 6 times 8, why would you point at me and laugh? Neither one of them is on the red list, for God's sake. So 48 makes me think 6 times 8. 6 and 8 went on a date, came back home with 48, that kind of thing. So sorry, that's out. And what's wrong with 4 times 12? 4's on the list, but 12's not dead. And so we search and search and search, and we find 16 times 3. And I'm giving these to you just again as a courtesy so that you know that they're coming, and when they come, you can attack them quickly. And you're going to see a theme, and you might think to yourself, why does 16 keep coming up? And it took me a few years to figure it out, but then I remembered, oh, that's right, dude. They only teach times tables up to 12s. And so whenever 16 is going to hang around and do his thing, it's like, how am I supposed to spot him when I really only memorized up through my 12s? You probably know where I'm headed with this, but here comes the next one. An 8 is just a death trap. First off, 8 times 10. Oh my God, that's terrible. 8 and 10 aren't even on the list.
Yeah.
What about 4 times 20?
The
20 is not dead. Don't pick it if it works. Pick it if it's the best thing that works. Did you find it?
16 and 5.
There's our guy. Which makes it what?
4 root 5.
That's the thing, is the question someone asks is, I'm seeing a theme here, so why is there 16 in all of your death numbers? And I just answered that, because no one thinks of 16s. You just don't think of them. Normal people know through their 12s. Normal people don't know 16 times 3 and 16 times 5. And surprise, surprise, you might want to know, you might use. Good job, Aubrey. Yes. 96 is 16 times 6. And so when I see 96, I will find other numbers that work. Like I would have stumbled upon 4 times 24, but I'm going to say no. 24 is not dead. So this is 4 root 6. And the last one that involves the number 16, and then I have a few other death numbers. And then I have a little tip, a little handy professional tip for you, and then I'll let you try some problems today. This is the last one. I mean, obviously, I could go on forever with 16s, but this is reasonably, I think, where a good place is to stop. 112. Like, who thinks in these terms? What's 112? It's not on your list, is it?
16 times 7.
It is actually 16 times 7. Right. Peyton makes an excellent, astute observation. Why did I not give you an excellent job of paying attention? Why did I look at watch the green up here on the TV, please. I gave you 16 times 2, times 3, times 5, times 6, times 7. Why did I skip 4? Because 4 is also rootable. And if it turned out to have been 16 times 4, it would have just been 64 in the first dang place. And what is the square root of 64? Just 8. So I'm not going to give you one where both numbers are on the red list. That's why I skipped. Great question. Rarely does anyone actually take the time to ask that question, so I appreciate you. What is the square root of 16?
4.
Okay, I've got one more killer, and then I'm going to show you my one more real killer and one more semi-killer. So this is a terrible one. I'm so sorry that this will come up, and don't fall for it. Assuming you attended elementary school or you were homeschooled and someone did their job and taught you your times tables, what is the conditioned response to 72? It is 9 times 8. You can just always tell who knows their times tables when you say put up a 72, 8 times 9, 8 times 9, 8 times 9, which is rad because 9's red, but 8's not dead. Well, that was a rhyme. So go deeper. 36 times 2. It's just generally not the way the human brain works. We're not inclined to want to go to those extremes. But in this case, it's what we actually do want to do, because I want that first number to be as big as I possibly can. And if I do 36 times 2, it is 6 root 2. Gorgeous. And then I got one more, and I could keep going with death numbers, but I'm just trying to list for you the ones that I see the most. And this is the last one. If you are a real master of your 4th grade times tables, you would know that 9 times 12 equals 108. That's like next level mastery if you know that one. And you go, oh, 9 times 12. But what's the problem with 9 times 12? 12's not dead. And so if the second number's not dead, you've chosen poorly. Let's go deeper. Does anyone know what 108 is? It is 54 times 2. But that does me no good because neither of them is on the red list, right? I mean, it's a sweet combination, but I need a red list. There's a trick, and I think this is a good time for me. I didn't think this would be the problem where I would introduce my trick to you, and it's honestly a very disappointing trick. You'll think it's really cooler than it is. It's more of a helper. I'm always telling you to look for red list numbers. Get used to it, because that's what I'm going to do for a few days here. Is just look for the red list. But interesting things can happen when I pull a stunt like what Aiden did. I don't know if you heard Aiden over here, but he said like he divided 108 by 2 and figured out that 54 and 2 work. Now I poo-pooed that because 54 and 2 are both trash. But along those lines, if you have a calculator handy, take the number 108 and divide it by 3. And I say this, if you're still listening, this should make sense. 3 is trash, right? 3 is of no use to me. But this is an indirect approach. Rather than worrying about the 3, what I'm mostly worried about is this idea, is that if I divide something by a small number, I get a big number. And I'm not interested in the 3. I'm interested in who his partner is, the 36.
6 root 3.
It is. So sometimes if you get, and I have a few examples to prove this point, sometimes on these bigger problems like 108 and the next ones I'm going to give you, it's best not to directly go and search for the red numbers themselves. Try dividing the really big numbers by little baby numbers like 2 and 3 and 5. And often what you'll find is the answer is what you were looking for in the first place. So if that makes any sense. It's a really cool trick for bigger numbers. So yes, on this one, I would break it into 36 times 3. And yes, it is definitely 6 root 3. All right, so these are the numbers that I wanted to show you the big number trick on, and then it's work time. So here we go. Here's the first one I could think of. I will tell you this, if you right now start dividing by 4, and then by 9, and then by 16, and then by 25, because you're like, I gotta find a red number, and then it's gonna take you a while. Let's take a much more interesting, let's take that backdoor approach. Yes, if I divide 288 by 2, again, I say this and I'll say it again and again and again. I'm not interested in the 2. I don't care about the 2. But if I cut 288 in half, I get this beautiful number. Look at that, 144. And we love 144 because he's red. What's the square root of 144?
12.
So 12 root 2 is our guy. Okay, here's the next big number. I want you to try this. Telling you again, don't look for, hold off a sec, okay? You're really fast and I want to give everyone a chance. You're not looking directly for the red list number. You're going to find him with a sneaky approach. It's an indirect approach. And feel free to use calculators for these next couple of days for their ability to divide and multiply numbers. Don't feel shame. You should feel shame if you use it for 9 times 3, maybe, but like not bigger stuff like this. Sorry, is that rude? That's what I'm looking for. It was good to hear a new voice. Aubrey's gotten really quick at this, so good job. And again, if you divide on your calculator, you hit divided by 3, you're like, I know I'm not interested in you 3, but I am interested in your partner, 121, right? I hope that makes sense. And so we get 11 root 3. We find that 121, even though we weren't really searching for him per se. Next one is the square root of 128. Yes, if you divide him by 2, throw the 2 away. But his partner is a beautiful 64. And 64 is square rootable to 8 root 2. The last one I have for you, and then it's work time. And I could keep going because there's infinitely many possible examples, but you'll learn just through the practice of doing this. And the numbers today don't go too high. The numbers tomorrow, I'm going to purposely make them higher. So you'll get a little more practice with the big number tricks tomorrow. Today's more warm-up-y. All right, here's your guy. You could search for, again, a very long time if you don't know the big number trick. Already got it, did you? Good. Yep, good for you. Looking at anything on print right now isn't going to help you because our list only goes up to things that multiply to make 100. So this is where you grab your calculator. And again, feel no shame. These are big numbers. But what you're doing, why Aubrey's so fast at this back there, is she's typing in 432 divided by 2. And then she got 216 and realized, no, throw that one away. And then she very quickly types in 432 divided by 3. And it's okay to use your calculator. Like we don't expect you to memorize multiplication and division problems that big. But when Aubrey and you guys all hit divided by 3, something great happened. What was it? It was 144. Correct.
Have a wonderful weekend.
I don't see you tomorrow.
No.
That's right. Have a good one. Okay. Good luck. I'll see you Monday. Yeah, your assignment is on Delta Math. It's assignment number 15. Oh, and I wanted to point out one more thing while I've still got this recording going. I posted on Canvas. I think I published it. Let me check real quick. Did I? Oh, I haven't published it yet. Hold on just one second. There, it's published now. On today's Canvas, I have what we're doing or what we just did, I guess. There'll be a recording here in a few minutes once I YouTube it up. But I also put, as I said I would, the answer keys to the last 2 assignments, the factoring ones that you've been working on. So today's Canvas is a huge place. It's got 2 answer keys and then soon to be a recording. Okay. All right. Yeah, go ahead. Aubrey, what's up? Yeah.
Your whole punch?
I do have a hole punch. It's over there somewhere. I don't know where.